Good evening friends. So today we will discuss about special type of fraction that is called precipitation reaction. Already we have discussed about the decomposition reaction, displacement reaction and the combination reaction. Okay, now today we will discuss about the last type of fraction that is called precipitation reaction. So let's start the lecture. Last and fourth type of the reaction is precipitation reaction. Okay, the word precipitate, meaning of the word precipitate. Okay, precipitate means insoluble product. Okay, what does the mean precipitate means? The word precipitate means insoluble products. Okay, and these insoluble products are shown by downward arrow in a chemical reaction. For example, if we talk about precipitation reaction, suppose you have two test tubes. In this test tube you add some solution of AgBr, silver nitrate, AgNO3. There is solution of AgNO3 and you also add another solution reactant, that is potassium bromide, that is KBr. Okay, and you have to stir it continuously with a stirrer. What happened in this test tube? There are two reactants, there are two salts. One is AgNO3. AgNO3 is silver nitrate. Second is KBr. KBr is potassium bromide. Okay, so after some time what happened? What is this? This is a stirrer, glass rod. It is also called glass rod, with the help of which you can dissolve the salts. Okay, after some times what happened? Now product, after some time what you will observe? You will observe there are two products. One is solution form, one is in solution form, clear solution, and second is insoluble product that settle down at the bottom. So this is reactant side. Why this is called reactant side? Because here we take two interacting substances. First interacting substance is AgNO3, second interacting substance is potassium bromide, and we add these two substances in a test tube and stir it with the help of a stirrer or glass rod. Then after some time what will happen? There is a formation of two products, two new products. One is in clear solution form and second one is in these form. This is insoluble product. This is first product, insoluble product, and this is the soluble product. Okay, So what we have two salts in a test tube. Name is AgNO3 silver nitrate, and second is potassium bromide KBr. These two are reactants. Chemical reaction happen. After chemical reaction we have two new substances with different properties. One is in soluble form, okay, one is soluble product, and second is insoluble product. Okay, the insoluble product is called precipitates. In any chemical reaction, the product which is insoluble in solution, that insoluble products are called precipitates, or short form में they are called PPTs. In short form, precipitates are called PPTs. Okay, now if I try to write this all procedure in form of a chemical reaction, so what we can write, we have two reactants. First one is silver nitrate plus second one is potassium bromide then what will happen? After some time, these two reactants when interact with each other, okay, then they will form new substances and a chemical reaction will happen. And what will be the chemical reaction? Product will be, first product will be silver bromide and second product will be potassium nitrate. This is the word notation of the chemical reaction. Now if I try to write their symbolic form, like silver nitrate, how can we write this silver nitrate? Silver has formula, symbol of silver. Silver is a metal, precious metal, its symbol is Ag. Okay, second is nitrate, nitrate is NO3. Clear? So silver nitrate formula is AgNO3 plus. Second is potassium bromide. Okay, potassium is again a metal. It is very strong metal, very much reactive metal. Okay, so its symbol is K. Potassium is represented by symbol K. Second one is bromide. Actually bromide is ionic form. Its neutral form is bromine, Br2. Br2 is bromine, and in ionic form it will written as Br1 negative. Okay, so here is bromide, so I will write here Br bromide, so it will form Kbr is potassium bromide. Okay, now after that, after some time when these interact, these reactant will interact. Okay, reactant, what are reactant? The initial substances which interact with each other in a chemical reaction, that initial substances are called reactants. Like if you look in this reaction, there are two metals. One is silver, this is silver. Second is potassium, this is potassium. Okay, now what will happen? If you look about the reactivity, how metals react or how elements react with each other or with other elements, like Ag is silver, it is very less reactive element. This is the reason why most of the ornament are made by silver and gold, because they are very less reactive. They cannot be easily react with air and remain for long time. Okay, so silver is very less reactive. On the other hand, if we talk about K is potassium, it is very much reactive. Okay, so due to this reason, what will happen? This K being more reactive, it will take place of silver Ag. It will take place of silver. Okay, what will happen? Being K is more reactive. Reactive means attacking. Okay, potassium is more reactive, so it will take the place of Ag. It will take place of Ag, and Ag will go in place of potassium, and a chemical reaction occur. And what will happen, what are the products, like with NO3, now Ag, in place of Ag what will come, K will come, KNO3. This is the second product plus first product. In place of K what will come, this Ag will come, and the first product is AgBr, and this AgBr is actually this insoluble product, and this insoluble product is silver bromide having formula AgBr, okay, and the soluble product is potassium nitrate, that is KNO3, okay. So in this reaction, after the completion of the reaction, though two products are formed, first one is AgBr, second one is KNO3. AgBr is in insoluble product, it is in insoluble form, it is not dissolved in the solution. So insoluble products are called precipitates, and short form of precipitate is PPT. PPT means precipitates. And whenever you have to write any chemical reaction, in a chemical reaction, precipitates means insoluble product. Insoluble product always represented by a downward arrow in a chemical reaction. So out of these two products, AgBr is insoluble product, means it is a precipitate. So to represent PPT, we will show it by a downward arrow. So anytime when in any chemical reaction precipitates are formed, against precipitate, against the product which is precipitated, we have to write this downward arrow. The downward arrow means precipitates. So we can write that precipitates in a reaction is represented by a downward arrow. So precipitates in a reaction shown by downward arrow, okay, where in any chemical reaction if you see this downward arrow, always downward arrow on product side means what they are a insoluble product, and insoluble products are called precipitates, short form is PPT. Insoluble products means that settle down at the bottom like this, okay. So this is an example of PPT reactions, precipitation reaction, okay. Again, precipitate means insoluble product. Insoluble products are called precipitates, shown by PPTs, short form is PPTs. And in a chemical reaction, any product which form PPTs, it is represented by a downward arrow. It means what this chemical reaction tell us, this chemical reaction tell us there are two reactants. First one is this is arrow. On the left hand side of arrow, that side is called reactant side. On the right hand side of the arrow, that is called product side. So left hand side is called reactant side. Always look students, this is the arrow, left hand side of the arrow is the reactant side, and right hand side is the product side. Like there are two reactants. Reactant means initial substances which interact during a chemical reaction. There are two reactants. First one is AgNO3. AgNO3 is called silver nitrate. Second is potassium bromide. Formula is KBr. So what will happen? How reaction happen? Because potassium is more reactive, it means it can attack with more power, okay. So due to the more power, this K will displaces Ag and remove Ag from here. So Ag will take place of K. What will happen? K will attach in place of Ag and Ag take place of K. So product, what will the product? Products are AgBr and KNO3, okay. And this arrow show the precipitate PPT of which product formed PPT are AgBr in this direction, okay. So what we can say that finally we will discuss the one more example of PPT reactions, okay. So about precipitation reactions, we can write that reactions which lead to the formation of insoluble products that settle down at the bottom. So reactions which leads to the formation of insoluble products that settle down at the bottom, and the insoluble products are called precipitates, and the insoluble products are called precipitates. Okay, and precipitates are shown by downward arrow in a chemical reaction. Okay, that reactions are called precipitation reactions. Let's do one more example. Like we have two reactants. First one is hydrogen sulfide, as in your book. It is in your book. Okay. First reactant is hydrogen sulfide. Look how we write the formulas of these reactants or products. Okay, nothing is in your syllabus, but a little bit I can tell you how we write these formulas. Okay, more things you will read in your next classes, in higher classes. Like hydrogen sulfide. To write hydrogen sulfide, first of all you have to aware about the symbols of the elements. Like you all know about the hydrogen. The symbol of hydrogen is H. Okay. Second is, with hydrogen what is written? Sulfide. Sulfide means when sulfur is written in its ionic form, that is called sulfide. Actually sulfur is represented by the symbol S. Okay, what is S? S is represent the symbol of which element? Sulfur. So if you write the sulfur in its ionic form, ionic means positive or negative species elements are called ions. Okay, so sulfide is written like this, -2. Okay, sulfur is represented by S, and whenever you have to write sulfur in its ionic form in charge form, positive charge or negative charge, then always sulfur is written as like this. Sulfur has got -2 charge. You have to remember this. Okay, up to this class. So, and on the other hand, if you talk about hydrogen got +1 charge. Okay, so always when we write the formulas, two things will be in your mind. First one is the symbol of the elements, second one is the charge on that elements. Okay, there is no concern of charge or valency to you up to your syllabus. Just if you want to remember the things, if you want to know more things. Okay, like hydrogen sulfide, how we write hydrogen sulfide. To write hydrogen sulfide, first symbol of hydrogen is H, symbol of sulfur is S, and the charge on hydrogen is +1, charge on sulfur is -2, and then we have to do cross multiply. After doing cross multiply, what we have, with H we got multiply by 2 and to S by multiply by 1. So H2S1, 1 is nothing, so we remove 1. So H2S, what is H2S? It is hydrogen sulfide. So now I write here the hydrogen sulfide H2S. I hope it is clear to you. Plus second reactant is zinc chloride. Okay, second reactant is zinc chloride plus zinc chloride. Now how will you write the formula of zinc chloride? Look here, zinc has symbol Zn. Zinc is also a metal. Second is chloride. Actually chloride is ionic form. In neutral form it is chlorine and its symbol is Cl2. Okay, so whenever chlorine is written in its ionic form, chlorine is become chloride. Okay, so how will you write this chloride? Like I put here the symbol of chlorine Cl, and zinc got +2 charge. You have to remember this. Chlorine got -1 charge, and when you go cross multiply it, what you have with Zn multiply by 1, Zn multiply by 1. Second is Cl is multiplied by 2, Cl is multiplied by 2. Zn means nothing, so I remove it from 1 is mean nothing, so I remove 1 from here. So now after this reaction will happen. These two are reactants in this case. H2S is hydrogen sulfide, ZnCl2 is zinc chloride. Okay, now look how reaction will carry out. So first of all, look at this. Zinc is a metal. Metals are always reactive. So it means zinc attack on this non-metal hydrogen. Okay, so what will happen, because zinc is more reactive, more powerful, so it easily take place of hydrogen. So it take place the hydrogen. Zinc take place of hydrogen. So zinc attack hydrogen. So what will happen? Ultimately H will go in place of zinc. So what will happen? Displacement also occur there. What type of displacement? Because there occur exchange of two positions. Zn goes here and H goes in place of Zn. So two displacements occur. So this is also called double displacement reaction. So two products are formed. Which two products are formed? Zn combined with S. It means zinc sulfide. First product is zinc sulfide plus second product H will go in place of Zn. So H when combined with Cl they form hydrochloric acid. You all know that. Okay, now I try to write formulas of these both, zinc sulfide and the second one is hydrochloric acid. Like zinc sulfide, you know that. Now I will write here. Now I will try to write the formula of zinc sulfide. It is very much easy for you if you capture the thing with me. Zn is zinc, second is sulfide. Sulfide is, you know that zinc carry +2 charge and sulfur carry -2 charge. Now you will go cross multiply. After doing cross multiply, what do you have? You have Zn2, S also 2. Okay, 2 is cancelled out by 2. So you have, what is the formula of zinc sulfide? ZnS. Okay, plus second product is hydrochloric acid. So hydrochloric acid, it is very easy for you. If you want to write it, hydrogen combined with chlorine, they form hydrochloric acid. Hydrogen has symbol H plus chlorine in chloride form. It has +1, it has -1. After doing cross multiply, what do you have? H1 Cl1. 1 is cancelled out. So what do you have? You have HCl. What is HCl? It is a formula of hydrochloric acid. So this is the one more example of which type of reactions? Precipitation reactions. The important thing is here, we have two products, one is zinc sulfide, second is hydrochloric acid. So which is the insoluble product? I mean to say, which form PPTs, which form precipitates. So zinc hydrochloric acid is in solution form and zinc sulfide will form the PPTs. Okay, so here I put the downward arrow, here also and here also. This downward arrow means, what does this downward arrow means? This product will show this product is a insoluble product, and these insoluble products are called, they are precipitates, and precipitates are written in short form as PPTs. Okay, so in this reaction, which product has PPTs? The product zinc sulfide, formula is ZnS. So and one thing also, this reaction is also an example of displacement reaction. What type of displacement? Because two positions are exchanged, Zn come in place of H and H go to in place of Zn. So this is an example of also which type of reaction? Double displacement reactions. Okay, so this reaction tell us about PPT as well as about double displacement. Okay, why double displacement occur here? Because zinc is a metal and it is much more reactive than hydrogen, so it take place of hydrogen, and hydrogen ultimately will go to the in place of zinc and reaction will happen. Okay, so only this much for today lecture, students. In next lecture we will discuss the next topic of this lesson. Okay, I hope all things are clear to you. Thanks to all of you.